and kind of do as much of this as we can. So this is kind of what you want to focus on. I think should be working okay. It's going in and out again today. Okay, so let's just kind of go over these together. Let's see what we know. Let's start with the basic stuff first of all. And, the harder part of this is to me, the further you get into the probability, the harder it gets. So, all right, what does this first problem say? What is the meaning of this symbol, that funky E? What does that tell you? Element of. So the question is E an element of that set? True or false? Okay, that's real simple. Okay, that one's true because it's there. Okay, that's what I'm testing you on that. Okay. Okay, all right, how about this? What does this symbol mean? The sideways U. Subset. Okay, so what I'm asking you on this is, and if it's a subset, I'm asking, is everything there also here? So we have a 2, 4, 6, 8. So true or false? That's definitely true. So that is a subset like that. So what you want to make sure that you know is the meaning of element and the meaning of subset and what those things are. Okay? All right. You know what an infinite set is. What does that mean? It's a set that has infinite numbers of things. A finite set is something you can count. Okay? So what this problem is saying is all even numbers greater than 10. Okay, well, what would that be? Okay, the even numbers greater than 10 would be 12, 14, 16, blah, blah, blah. So is that infinite or finite? That is definitely infinite. Okay, all right. Okay, the next one says all the prime numbers less than 13. Well, one thing that you want to make sure that you know, and you can write this down on your test, on your note card if you have to. What's the first prime number? 2. Okay, then what? 3, 5, 7, 11. You can figure it out. It's just the numbers that only divide by itself and 1. So anyway, would that be a finite set or an infinite set? It says the prime numbers less than 13. Yeah, that's definitely finite. So that set would just be this. It would be 2, 3, come on, I can't write. 2, 3, 5, 7, 11, and that's it. Those are the prime numbers. So that one is a finite set. Okay, so these are just kind of the basic terminology. So if you've got this down, this won't be the harder part of the set. Okay, let me ask this question. What is a disjoint set? What are two sets that are disjoint? What does that mean? Good, no intersection. Okay, a lot of vocabulary on this. So there's no intersection, right? Not disjoint means there's an intersection. Okay, so what the question is on this one is A intersect B disjoint or not? Well, let's figure out what A intersect B is. Okay, is there anything in common between those two sets? Okay, right? So we would end up having A intersect B is the empty set, so that means they are disjoint. Okay, that's what that means. So there's a lot of vocabulary here at the beginning that you have to make sure you know. Okay, all right, let's figure this one out then. Okay, this set A, all even numbers. Now that says all even numbers, so that would be 2, 4, 6. Is this an infinite set or a finite set? All the even numbers. That's infinite. Okay, good. Okay, B says all positive numbers divisible by 5. So what would be the positive numbers divisible by 5? 5, 10, 15, 20. Is that infinite or finite? Yeah, that's definitely infinite like that. All right. So what we want to do on this then is what we're looking for the intersection of those two sets. So are there any numbers that are even and at the same time divisible by 5? Yeah, there's a whole bunch of them, right? Okay, so what are they? There you go, 10, 20, blah, 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 like that. So that's not disjoint, okay, like that. All right, that's the idea. Disjoint just means the intersection is empty, okay? So some of this stuff here is just testing your vocabulary ability here a little bit. Okay, this one you gotta be careful about this one, okay? Again, what's that funky E mean? Element. Okay, now this one you gotta be careful about. A is an element of that set, but the problem is this is saying, is this set an element? That's not true, okay? If it was written this way, if I wrote this problem this way, A is an element of M, A, T, and epsilon, that's true. That is true, but this is a set, so it's false. That, to me, is the most difficult thing to wrap your head around on page 1, is that, yeah.
Also, because the A to the left of the highlighted E has the...
It has a set brace on it.
So that means...
See, an element is not a set. An element is just some part of that set. So that's why I was saying, if I wrote the problem this way without the set braces, then it's true. Okay? Now, what if I did it this way? What if I wrote set of A is a subset of M, A, T, epsilon? Is that true or false? Yeah, that's true. So it's just kind of the notation on that. Okay, this is false because I'm asking if a set is an element of the set. No, it isn't. It's a subset. Okay, does that make any sense? Okay, that's picky, but that's, part of what I'm looking at is vocabulary on this. All right. Okay, so you guys got that down. Again, what's disjoint? Intersection is empty, okay? And then you want to know the difference between finite and infinite sets, subset, and the idea of an element. That's just all vocabulary on that page. Okay, so what I tend to do on this exam 3 is I tend to do a lot of vocabulary, on the multiple choice part. The short answer part, what I do on this is just with no partial credit, just kind of right or wrong. So let's kind of go through this stuff fairly quickly since we've been doing this for a long time. Okay, so A union B, okay, remember what you're doing on A union B is, what are you doing? When I ask you to do a union of two sets, what do you do? Combine them, but what is the one thing you don't do? Repeat anything, right? Okay, so what you do, and I don't care what order you write this in, if you're doing the union of two sets, you just write everything down. Okay, there's a 1, there's a 2, there's a 3, but don't repeat the 3. Okay, then there's a 5, but don't repeat the 5. And then there's a 7, again, don't repeat the 7. And then there's a 9 like that. Okay, so that would be the union of your two sets. What order you write that in, it doesn't matter. I just try to do it numerically like that. Okay, and let's see, how about the intersection? Do these two sets have an intersection? Yeah, what's the intersection? Good, 3, 5, 7. Okay, so you guys sound like you're getting all this stuff down. Okay, 3, 5, 7. Okay, that's good. All right. All right, what is the next thing? A prime, what does that tell you? Complement. It's not an A, but it's in U, right? Okay. So what you do on this is it's not just everything outside of A, it's everything outside of A that's in U. So what I'm going to do is do this. Okay, there's a 2 in A. I'm going to mark it out of the universe. There's a 3. I'm going to mark that out. There's a 5. I'm going to mark that out. There's a 7. So it would be everything left over like that. So that would be your answer right there, is those things right there. So a complement would be 1, 4, 6, 8, 9, 10, like that. So that's your complement there. Okay, that's a set. All right. Okay, and so just kind of have a strategy for keeping track of stuff. That's why I kind of show you to highlight and scratch out like this. Okay, this one, what does that N tell you? Number of. So this is saying the number of elements. It's not asking for a set, it's asking for the number of elements in B complement. Okay, so what we got to do is figure out what B complement is. I do the same thing. What I'm going to do is I'm going to mark out everything in the universe and just kind of do that. So 3, I'm going to mark that out. 5, going to mark that out. 7, going to mark that out. 9, I'm going to mark that out. Okay, just got to have a strategy for putting this together. So that's what B complement is. B complement is 2, 4, 6, 8, 10. So what's the answer to this problem? 5. Okay, remember, this is asking for the number of elements, so it's a 5. So much of this stuff we're looking at is vocabulary and understanding the symbolism. I'm not asking for a set on D, I'm asking for the 5 elements that are there. Okay, you with me there? Everybody good? Go ahead.
C and A asking for the same thing.
What's that?
C and A. Option C.
Well, they're both asking for sets. You know, the union is just join the sets together but don't repeat any element. But A prime is asking for the complement. That's asking for everything that's in the universe that's not in A. That's what that is. So that's asking for a set. So is B.
No, D.
Oh, D. D is just asking for how many things are in the complement. So I think you're asking, is B complement the same idea as A complement? Yes, it is. But what you're doing, the difference on this problem is I'm not asking for the set. I'm asking you how many things are in that complement. That's the difference between the two problems. Okay, now I got what your question was. Okay, all right. So let's kind of begin to look at this stuff now. And we spent quite a bit of time on this because it's had so much to do with our probability. So what we're doing on this, you got to know what all these numbers represent in here then, okay? And this is just basically telling you the sets. These are just things that are inside the set. These are not necessarily numbers of elements. These are just things that are in that set like that. Well, let's start at the easy place. To me, here's the easy place. Okay, so what numbers represent the, hold on, not that one. Let's do the first one. What represents A intersect B in this diagram? Okay, remember the intersection is this part right here. So hopefully we've done enough of this in class and on homework that you're beginning to get all this stuff down. Okay, so again, I'm not asking you to add those things. I'm not asking for the number of elements in there. I'm asking what those elements are. So that would be 3, 7, 11. I don't care what order you put that in because it doesn't matter. Okay, so that's what that is. All right. So I think students usually have that down okay. All right, when I'm looking for A union B, what are you looking for? Butterfingers there. Okay, all right, I can grab those for you. I need to get off my tail every now and then anyway. Okay, so what am I looking for in the union? Yeah, it would be everything inside of both of those sets. Okay, now again, you don't want to repeat anything when you do that, so don't repeat anything. So I'm just going to shade this kind of as I go. You don't have to do that, but it would be all of those things that are in both A and B. Just write them all down, but don't repeat anything. So I don't care what order you put that in. I'll try to put it in numerical order. You have a 1, you have a 2, there's a 3, there's a 4, all right, no 5, there's a 6, there's a 7, and there's a 9, okay? The order you put that in, I don't care, doesn't matter, okay? So that's the difference between the intersection and union. Everybody got that down? You feel like pretty good? What's that? Oh, I did forget 11. Thank you. You're a keen observer. Thank you. Okay, so now we're good with that. Those are the basic ones that you have to know. Okay, so I'm going to erase that shading. I'm just using that as I'm going through this. Okay, now this one, what are you doing? You're doing A union B, but what does that prime tell you? Outside, good. Okay, and if you need to write notes to yourself to study on this, that's helpful. So you're outside of A union B. Okay, well, what would be outside of the union? The union would be all of these things here that I'm highlighting in blue. So what's outside? The 8, the 5, the 12, and the 10. Okay, so we have that. Okay, again, I don't care what order you put that in, it's whatever. Okay, so we got that. Okay, so that's what that means. To me, the part D and E are the hardest things for students. So I'll kind of go back and review how I taught you how to do this. You want to kind of look, anytime you're looking at an intersection, you're looking for an overlap, okay? So this is the way I would piece this together is like this. I would just probably go through and maybe put a check mark by everything that's outside of A or highlight it or something. I think I'm going to highlight it this time. So everything that's outside of A, that would be a 8, a 5, a 6, a 12, a 4, and a 10. Okay, that's everything that's in A complement, right? Okay, now I'll pick another color like pretty green here. Now I'm going to highlight everything that's inside of blue. or no, everything is inside of B. So that would be a 3, 7, 4, 6, like that. So where do those things intersect? 4 and 6. That's what I tried to do, was show you that that would be the things that I highlighted in both colors, see? Okay, so that would be this, and it would be this. Okay, use a check mark, use a system that helps you figure that out. You guys understand what I did there, or do I need to do that again? Do it again. Okay, I'll do that, because sometimes it's kind of hard to, you might not keep up with what I'm doing on that, okay? Let me do it this time, I'll do check marks, okay? Let's do everything that's a complement. Outside of A would be 8, 5, 6, 4, 10, 12. That's what that is. Okay, now I'm going to do another check mark by everything that's inside of B. Inside of B would be 3, 6, 11, 7, 4. What did I check twice? 6 and 4. Okay, because it's an intersection. We're looking at what's in common. So that's a good strategy to use, is either use highlighting or check marks. Okay, did that help you with that? You okay with that now? Okay, everybody good with that? Okay, all right. So that's kind of the strategy I try to teach when I do that. It's just that same kind of thing. And probably the next problem is probably good to approach the same way too. So I'm going to do this. I'm going to put a check mark by everything that's in A. So we have a 1, 3, 11, 7, 9, and a 2 like that. Now I'll do a check mark by everything that's outside of B. So remember, B prime is B complement. So put a check mark by everything that is outside of set B. Okay, so I think I've got that now. So here's kind of what the deal is on this. When you're doing a union, we're not doing an intersection. So it's not the things I checked twice. It's everything I checked, but don't repeat anything. The only thing I didn't check on this problem was that and that. So it would be every other number on that then. Okay, so again, you just put it together in any order you want to. Just don't repeat anything. I'll put it in numerical order. So I got a 1. I checked the 2. I checked the 3. I didn't check the 4. I checked the 5. I didn't check the 6. I checked everything else. So that would be 7, and then 8, 9, and 11, like that. Now, see, that's a union. So a union is not what you checked twice, it's what you checked, because you're putting it together. Does that make any sense? Right, there's a difference between those two, so you got to pay attention to what we're doing with the union and what we're doing with the intersection like that. All right, so use that strategy. You got to be really careful about checking things off and clearly understanding what I'm asking on each problem. Okay, so to me, the hardest things on this would be like when you start dealing with, you know, intersections and unions of complements. It's a little bit more thoughtful when you're dealing with that. Are you all good with that? Tell me. Good, bad, indifferent, what? How do you feel? Okay, well, I know Corey does. Everybody else okay? Okay, all right. To me, these are the simpler things. The further back we go in time, the easier the material is to me. Okay, you've had a little bit more time to absorb that. Now we're going to focus mostly on probability and odds and things that we've been working on more recently. Okay. Okay, probability usually starts off real simple for students, and when you start getting into or and conditional probability, that's when it gets harder. Okay, but you got to know what formula to use and everything. All right, so I've got a spinner here, and what we're going to do is just figure out some probabilities based on this spinner here. So first of all, if we're doing the probability of 4, of hitting a 4, what do you look for that goes in the denominator of that probability? Everything that's possible. Okay, so there is basically what? I think 12. Am I counting that right? 1, 2, 3, 4, 5, 6. Yeah, that's 12. So it's something out of 12. There's 12 possibilities. All right, what are you going to look for in the probability of 4? You're going to look at how many times 4 occurs, right? How many times does 4 occur? Twice. So that means it's a 2 out of 12 probability, okay? And when you get in next week's test, I'm going to expect you to have every fraction reduced two choices. You can either use your calculator or you can just do it by hand. I don't care which way. I would hope that you could do some of the smaller numbers in your head, but if you need to use your calculator and everything, it's okay. If I go 2 divided by 12, I get that. Then I go math, convert fraction, just press enter twice, and it'll give you 1/6. So I'm looking for reduced answers. You don't want to lose any points because you forgot to reduce your fraction. And you got a calculator that'll help you and bail you out of that situation anyway. Okay? Right. So that's kind of how we do that then. So what we're looking at here in this problem is the basic probabilities. Okay, it's always going to be out of 12. Okay, what are you going to do with the even numbers? What do you look for? You look for all of the even numbers on here. So I see a 4 popping up. I see a 4. I see a 2. No, let's see. Make sure I got everything. I think I got everything. So what's that? That's 4. Okay, there's 4 ways to get an even number. So that's a 4/12 probability. That fraction you could reduce down. You could divide both things by 4. You get 1 out of 3. Okay, so that's what you're looking at in that particular problem then. Okay, now you got 2 approaches to this problem here. It's an OR probability, so I'll show you 2 approaches on this. The first approach is we have a formula for an OR probability. One thing that I'd recommend you do, unless you've got it memorized on the note card I allowed you to bring in, you might want to write down if the teacher asks for an OR probability, it means the probability of A union B, OR is union. So what you do is the probability of A plus the probability of B minus the probability of both, which is the intersection. Now you could bypass using this formula on this problem because the intersection's empty, but to be safe, that would be a good way to do this problem. So what I'm going to do on this is just write down probability of even union odd. This problem, I'll show you how I can do this in your head anyway. So you would do the probability of even plus the probability of odd minus the probability of both. And you don't have to do this problem this way, but you can. Okay? I'll show you why you can bypass the formula here in just a second here. So first of all, we know that there's 12 possibilities on this. So what I'm going to do is I'm going to highlight all the even numbers again, which is a 4, a 4, a 2, and a 2. Okay, so the probability of getting an even would be 4 possibilities out of 12, like that. Okay, well, the probability of odd would be everything else left over. You could reason this problem out easily in your head if you think about this. Okay, so basically we would have that, and that would be 8 out of 12. Is there any intersection? Is there any number that's odd and even at the same time? No. Okay, so you'd have that. Now, you could do it this way if you wanted to, or you could do this in your head. Aren't you absolute certain to get an even or odd number? Isn't it absolutely certain that one of those 2 things is going to happen? So see, what would happen on this is you would get 12 out of 12, which would be 1. So the answer on that's 12 over 12, which is 100%. And you don't have to use that formula, but, to be safe, you want to think about, if I ask for an OR probability, that formula will always get you to where you want to be, okay? Or that one is just 100%. You can think of it that way if you want to, okay? All right, how about this next one? The probability of getting a 6. That's 0. There's not a 6 to be found in that problem, right? So that's 0 out of 6, so that is 0. I like to usually test somewhere over something being certain, 100%, or something being impossible, 0. Okay, so I've got the certain event on C and the impossible on that. Okay, so that's a spinner problem. Those are pretty basic. If you know the basic concept behind probability, you can generally figure those out okay. Are we clear with that? Yes or no? Tell me. I have no clue. I can only read your face, but not your mind. Okay, all right, okay. So we'll kind of build up to the ones that start getting a little bit harder here. One thing that you want to make sure that you know about odds, and again, these are things that you can write on your note card. I'm going to write the formula out here at the side. So And you're going to have a lot of formulas that you need to write down because I'm not going to give you any formulas. You have to figure out what you need to know on your note card. So basically it goes like this. The odds for an event, you guys know what that formula is yet? Has to do with probability. There's two probabilities. I'll take that as a no. You do the probability of the event happening over the probability of the event not happening. Okay, that's what odds for is. So that would be the probability of it happening over the probability of it not happening. If you do it backwards, if I ask for the odds against, then it's backwards. It's the probability of it not happening over the probability of the event happening. So if you don't know that formula, write it on your note card and write down what it means, okay? So here's basically what we're going to do on this. I've given you the odds on this. So if I give you the odds, you can convert it back to a probability. So the other thing, if you need to write this down, you could write this like this. So if I gave you the odds for being A to B, then that means the probability of is A over A plus B. Okay, you can do this problem in your head, but that's the formula. If I want you to get the probability, let me write it this way. If I give you the odds against, and if I give that as A to B, it's the same formula, then it would be the probability of something not happening would be A over A plus B. Okay, so what you can do on this problem, you can do this in your head. I'm saying the odds for are 2 to 1, so I want the probability for. You know what the answer to that problem is in your head? What's the grand total between 2 and 1? 3. So what's the probability? 2 out of 3. Okay, what you do on this problem is you do 2 over 2 plus 1, so that's 2/3. Okay, that's how you convert odds back to probability. Okay, that's how that works out. Okay, now
it's the same equation for both.
Yep, and the thing is this. Okay, if I give you the odds for, this is the probability of it happening. Okay, but if I give you the odds against, yes, it's the same formula. But the thing you got to pay attention to, odds for can easily be translated to probability of. Okay, something happening. If I give you odds against, then that would mean the probability of this not happening is that. Okay, so that's how that goes. Okay, all right. Okay, how about the next one? Do you know the answer to the next one in your head? This is another basic thing we learned. If the probability of something happening is 35%, what's the probability of it not happening? 65, right? Okay. So another thing that we learned, was this. I mean, this is a formula you could write down, but you don't have to. If you were looking at the probability of is always 1 minus the probability of something not happening. Okay, so that would just be 1 minus 0.35, so that would be 0.65, like that. That's just kind of a basic thing about probability that you want to know. Okay? Okay, any questions? Okay, you just got to work with this stuff. It's not hard. Really isn't. Okay, now we'll get to the good stuff. Okay, I think the part 3 of this review is probably what you need to spend your most of your time on. So this says given, and what I'll do on the test is I'll give you 2 things. I'll give you a picture of the cards, because not everybody in here plays cards. And I'll also give you a picture of the 36 dice, just to save time. It's easier to do those problems if you can see something visually on there. Okay, so again, what we want to do on this, we want to do probabilities. Okay, the first thing is, when you're dealing with cards, are you dealing with a combination or are you dealing with a permutation? What's the difference? What do you look for? In a combination, what's the deal about order? Order does not matter. Okay, that's something you need to know, or you need to jot down on your note card. That's the key to knowing whether something's a combination or permutation. A permutation, order matters. A good thing to kind of get wrapped around in your mind is an example of each. To me, cards is the perfect example of a combination. You're dealt 5 cards, it doesn't matter what order they're given to you, it's still the same. Oh, this is 1 card. Yeah, so we're not going to do that on the 1 card. If we have a permutation, what's a good example of a permutation to you? Where order matters. What's that? Yeah, but remember, when you're doing permutations and combinations, you're doing more than one thing. You're not just picking one thing, you're picking multiple things from a group. What's a good example where order matters? So it's something we've done. What's that? Yeah, order matters on a combination log. To me, a good example is I've got my students here today, and I say, I'm going to pick 3 of you, and I'm going to give 3 of you a job. You're the president, you're the vice president, you're the treasurer. Order matters then. Okay, so that's kind of, you want to have a good example in your mind of an example of each. Okay, now this one we're only doing 1 card, so we don't have to worry about that so much. Okay, all right, so what we're going to do on this is, here's the key. I'm seeing an or probability. I mean, this is something I can tell when I was helping you guys last couple of classes you don't have down yet. When it's an or probability, there's a formula, right? And that formula is the one that goes like this. If it's an or probability, you need to immediately pull out this formula right here. Okay, that's equal to probability of A plus probability of B minus the probability of both, which represents the intersection. So that problem, I think a lot of times students try to overanalyze it. Don't do that. Just write down your formula. So what we're going to do is we're going to do this. We're going to do the probability of getting a face card plus the probability of getting a heart minus the probability of both. And you can write both there in words because that's what an intersection is. Okay, I don't have that diagram put up here, but let's just kind of see how much of this you know. Okay, so how many face cards are in a deck? There's 12, right? Okay, there's 12 face cards. That's the Jack, King, and Queen. And that's another thing you might consider putting on your, note card. If you need to write down how many of these things face cards there are, you can. Okay, how many hearts are in a deck? 13. Okay, 13 out of 52. Okay, how many cards are hearts but are also face cards? 3. Okay, remember there's 12 face cards, 4 suits, so 3 of them are going to be both. Might be a little bit easier if I had that diagram to display on this problem. So that's it. It's an or probability, so immediately that's what you think of. Okay, you think of that formula. Okay, well that would just be 25 minus 3. So 25 minus 3 is 22, right? So that would be 22 out of 52. And then you can convert that, just reduce the fraction. You can reduce that fraction on your calculator if you want. Well, that would be, divide by 2, you would get 11 out of 26, like that. Okay? There's 12 face cards. There's 13 hearts. There's 3 cards that are heart face cards that are hearts. So that's how you do that. All right, what do you think? Okay, you guys make sure you train yourself that if I ask for an or probability, that's the answer right there. That's what leads you to get into the right place. Or probability, that's what you focus on. Okay? All right, let me erase some of this stuff over here at the side. Okay, now what I'm looking at on this is the difference between an and probability and an or probability. That's kind of the key thing on this. So if I'm talking about and, what does that mean? That means intersection. Now you don't have to really pull out a formula on this. You can look at something. Let me go back and let me see, maybe grab that picture of the cards here real quick. Because what I'll do is I'll give you I'll give you a sheet with this diagram on it, and I think this will be helpful to you. Okay, this is an AND probability, so that means what it's talking about is it's talking about an intersection. So basically, your total focus on this problem is thinking about what the intersection of these two sets is. Okay, so this is the way I would look at this like this. Okay, we've got black cards, and you can do this in your head. Those are your black cards, right there. Okay, my kings are these cards here. What's the intersection? How many things are in the intersection? 2. Okay, there's only 2 cards in the deck that are black kings. So you don't have to do this. You can do this in your head. But if you as a student are not real familiar with cards, you can figure it out that way. So actually all you do on this is you've identified there's 2 black kings out of 52. So that would be a 1 out of 26 probability like that. Okay, so what you want to make sure you know on that, if it's a OR probability, that's the formula that'll get you there. If it's AND, you just have to figure out the intersection of those 2 events. So in that case, it's 2 out of 27, 52. Everybody with me? Okay, I've been saying that a lot in class. OR is union, AND is intersection. That's critical. Okay, that's what your thought process totally becomes, is when you're beginning to sort these things out then. Okay, let's see. Let me, on this next one, let me go back and grab that picture of the dice, because that's always a little bit easier to explain that same way. So let me see where I put that thing here. There's the dice, okay. And probably what I'll do is when I make up the sheet with these diagrams, I'll probably give you, several of these things so you can write over it and kind of use that to help you figure this stuff out. Okay, so let's see what we got on these 2 then, okay? Again, these are just basic kind of probabilities. So if you roll 2 dice, there's 36 possibilities, like we talked about. So some less than 5. Well, you can look at your diagram, okay, and you can just kind of shade or whatever you want to do. Identify everything that has a sum less than 5. Come on, work. Like that. Okay, so that would be a sum of 2. Those 2 would be a sum of 3. Those would be sums of 4, and it's got to be strictly less than 5. So that's what 1, 2. That's 1, 2, 3, 4, 5, 6 possibilities, right? So you would end up having on this 6 out of 36. Okay, and that would reduce down to 1/6, right, like that. So there's no formula that really applies to that problem. I'm just saying one event like that. Okay. All right, now you got to check this one out carefully. It's an OR probability. So what's your thought? It needs to be this. Okay. Immediately you need to think of that. All right. So what I would do on this one is I would start by writing this formula here, but write it maybe in words. It would be the probability of doubles plus the probability that the sum is less than 6 minus the probability of both. Okay, so what you do is I got an OR probability, so you need to immediately go to that formula. If you do that, you got a good chance of being very successful on this then. Okay, how many ways are there to get doubles? 6, okay. There they are. That diagonal, those are doubles. Okay, so that would end up being 6 out of 36. Okay, now I'm going to do the sum is less than 6. So I'll kind of circle these things. Okay. And it's got to be like that. Okay, so I've got, it can add up to 2, add up to 3, add up to 4, add up to 5. Okay, so the sum less than 6, if you count this, would be like this. It would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there's 10 ways to get that down. Did I miss something?
The sum is 6.
Oh, yes.
The sum is 6, not less than 6.
Oh, the sum is 6. Thank you. Okay, I knew I was doing something right. Okay. I was thinking, for some reason, I was thinking less than. Okay, so sorry about that. Okay, that makes the problem a little easier. Okay, so okay, so the sum is 6. Well, if you look at the sum is 6, that would happen here. It would happen there, 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 and there, like that. Okay, so basically what you would get, so you'd have 6 out of 36 ways to get doubles. And again, this was supposed to be sum equals 6. So there are 6 ways to do that. What's the probability of both? Nope, 1, right?
Oh, yeah, 1.
Yeah, that's where they intersect is right
No,
here.
no, I got you.
That's doubles and adds to 6. So that would be a 1 out of 36 probability of both. Okay, so this is the way you would work out the problem like that. Okay, so that would be 12 minus 1, that would be 11 out of 36. Okay, you guys with me there? What's that? There's 6 doubles. There's 6. Oh, there's 5. There's 5. Yeah. Okay, I'm getting a little sloppy here. I'm sorry. I highlighted 5 green things. Okay. All right. So thank you. So that would be 6 out of 36 plus 5 out of 36. So that would be 10 out of 36, and then you can reduce that fraction. Okay. Okay, and let's see. You can divide by 2, or you can use your calculator. That would be 5 out of 18. Okay, so that's how that goes then. Okay. Okay, well, that'll kind of get us through the basics. Now, what I'm going to do is Friday, I don't have to come into my office Friday, so I'm going to record the rest of it. So I would, over the weekend, go to D2L, and I wouldn't wait until I review this the hour before the test. That's no good. I mean, you want to go over and make sure you go over the rest, but watch the video, okay, and spend a little bit of time on that, because that'll be some of the harder types of problems. And spend some time looking at that, and then we'll wrap that up next Monday before we take the test. We'll review a little bit more on that then, okay? If you can sort everything out, you'll do fine. You just got to get all your formulas and get everything kind of sorted out in your mind and put the correct amount of time into it.